Welcome to a demonstration on the new Orthophoto from Point Cloud creation tool in Trimble Business Center version 3.90. So let's look at how we create an orthophoto from a point cloud. So typically you start with a point cloud object from scan data, whether that's from terrestrial, airborne, or mobile LiDAR, and that's a three-dimensional object. Next, we define a plane. So a plane you can think of like a user-defined coordinate system that can be defined in any orientation in three-dimensional space. Then we project the three-dimensional point cloud on to the face of that plane, which in turn creates a two-dimensional orthophoto, or you can think of it like an image. And the purpose for this is to allow the user to now have a two-dimensional view of the point cloud data to provide ease of use for generating CAD deliverables. As well, this can be exported out as a georeferenced image or a DWG file for use in a CAD package. Now we'll look at an example of creating the orthophoto in TBC using a point cloud dataset from the SX10. So here you can see a dataset that was collected of a topographic area in a downtown city center. The object of our attention here for this project is this building here. In a lot of examples for the use of the orthophoto, it's for vertical or non-horizontal structures like building facades, retaining walls, and things like that to create two-dimensional objects from the point cloud data. If we take this building as an example, let's say we want to model the front of this building and create an orthophoto from the point cloud. You see we have a fairly dense point cloud covering the front of this building. Now under the point cloud tab, we have the orthophoto command. I select the create orthophoto. So this is a fairly straightforward command where you define the type of orthophoto you would like to create. So this is using the intensity values, the RGB values from the point cloud to create an image, whether it's from the depth information, the gray, scaled, color-coded, or true color intensity. In this case, we'll use the true color intensity as we want to get more of a real world-like image. First, before I continue with the orthophoto, I'm going to segment my data down so I only have this building here. I don't want to use the rest of this data. Notice in the command we do not have a selection option here for what point cloud being displayed. The purpose for this is to provide a streamlined workflow within the command for the user. In this case, I want to only take the front of the building. So I can simply rotate my view and I'll segment out a chunk of the point cloud. Let's go with this area here. So next I'm going to name the orthophoto. We'll call it front of building. And now we'll define the plane. As I mentioned before, this can be defined for any orientation within three-dimensional space. So I select the drop down, hit new. This brings up the plane definition manager. This is where any plane you create in your project is stored. So I can have several different planes, maybe for each side of the building, maybe for the top of the building, for the building floor plan view, and I can also manage those here. So if I select new, it will create a plane. I'll give that plane a name. So in this case, we'll stick with our theme and say front building. There's a locked option here to prevent any edits to the plane. And then there's several options for how that plane is defined. One of my favorite, especially for building facade mapping, is using the vertical plane. This requires 2-point selections, so it'll create a plane in a vertical space along the vertical axes. So in this case, the z-axis, defined from those 2 points. So if I zoom into the building here, let's select maybe a point here and a point here. Notice it's created a plane now. If I scroll along, you can see it slicing through those 2 points along the z-axis. But notice there's also an axis defined within the plane. You can see there's the green, blue, and the red arrows for the coordinate system axes. The next is the position field. So this selects where the origin of the plane is located. So I'm just going to select somewhere maybe on the lower corner of the building. and it'll move the axes there. Alright, perfect. So we've got our plane defined. I can close that. And now the view automatically switches to show perpendicular view to the plane. This is to make it ease of use for the user without having to scroll and rotate the 3D view. We automatically perform that within TBC. So now I can select the image rectangle, so essentially the extents of my image. I don't want to select all of this extra area here, so I'm just going to select the data that I want. So I'll select my first point here and then drag. Maybe I don't want to include that bush, so I'll select there. And we also resize the view of the plane within the command so you don't have all this extra orange that's showing in your screen. The next definition is the pixel size. This is the relation of the pixels to the actual image size. And you can see, so right now I have this at 0.01. I can change that to, let's say, 0.02. And at the bottom here, our image info box tells us what the results of the created orthophoto will be. So the rectangular size, the image size, resolution, and total pixels. It's important to note here that the final image size will be rounded up to the nearest pixel size value. So notice here, 7.331 versus 7.34, we rounded that value to include all of the specified rectangular size, but to the nearest pixel size value, which in this case was 0.02. So I want a fairly fine definition here, so maybe let's go 0.01, 1 centimeter roughly. And that's going to create an image that is 770,000 pixels in total. So once that's all good, I can hit store, and then the image will generate. Okay, the image has been created. Close out of the Orthophoto command, and now you see we have a new georeferenced image here in our project, and that's the Orthophoto. So I'll turn off my point cloud data, and we can see the type of image that was created. So notice that there's still some granularity to the image. It almost looks like a bunch of sand, but it's also a 2D object in three-dimensional space. So it's important to note that quality of your orthophoto will only be as good as the density and the quality of your point cloud data. Now if I go into the cutting plane view here, you can notice that when I select the same defined plane I used before, the front of the building plane, I can now view the orthophoto in the cutting plane and use that as a 2D view. So all of my CAD tools, my editing tools, and my text tools will work in this view. So I can create building map here, print and plot to a Dynaview, and I have a finished project. So I'll show a quick example of this. I can use the polyline command. I can choose a name, let's say window, and maybe we'll change the layer to something like building sod. I can choose an elevation or leave this, and I can choose to connect ends. That's fine. So let's just draw a quick line here and demonstrate how I can do this. Select. And another important note is the OrthoSnap command, as you can see down here, also works within the cutting plane view. I can draw orthogonally to my objects, which is very valuable. So I've created that. Now if I turn off my georeferenced image, you can see my created CAD line and on the plane. I can also go into the Project Explorer. Under imported files, notice there is now a front of building TIFF file. This is the ortho image that was created. I can right click, select properties, and view some of the properties about the image that was created, such as the three-dimensional coordinates of each corner. As well, I can go to the export command, select the DWG or the ortho image exporter and use these. I'm going to use the DWG, so I'll select my ortho image, it's selected. I'll choose a file name, that's fine there, and I'll export. Okay, now in my file folder I can see I have my created DWG, so I'll open this up in AutoCAD. In AutoCAD you can see that I have the ortho image, and I can do any CAD line work here, such as creating lines on the surface of this image as well. This concludes a demonstration on the new Create Orthophoto command in Trimble Business Center version 3.90.